basically. So there are only few questions, and then we can have a few minute discussion and move on. The first question is from Guillaume Lopez from Chin. If you all can open your the presenter, open your video, appreciate it. The question is, polymer flood reduces carbon footprint compared to water injection, but how much is on average the increase of CO2 emission per barrel produced compared to primary or production?
Hi, so this is Jan Nieuwerf again from SNF. Guillaume is not here, I think.
Okay.
Yeah, so the issue is that the actual barrel produced with a polymer has a lower CO2 footprint than the barrel produced with on primary at large. Now, of course, primary production at the beginning is perfect, so nobody can win with that. Let's face it. But in the later part of the field life, when you start to produce water, that is when either a surfactant polymer or a water flood will help you, and that will lower your CO2 footprint on the barrel produced. And that's actually what Guillaume and what I were trying to relate in the paper we wrote at that.
Okay. There's another question in the hardness here. What hardness or any other parameter affect concentration of alkali, surfactant, and polymer in ASP Slug? If you can, and comment on that, I appreciate it.
Well, I also have to have a little look at Antoine for those numbers. The absolute numbers I don't know by heart, but in general, surfactant is pretty resilient on hardness, and of course surfactant and Jero can of course she's the expert here for the surfactant. Is the salinity is dependent. The efficiency of your surfactant is dependent on salinity. The polymer will degrade with higher salinity and especially with higher hardness and higher temperature. So you need to play around with that a little bit. There are no hard numbers for that because the family of polymers have grown so much that we can do higher hardness and we can do higher salinity and we can do higher temperatures. In general, the surfactant are not, they are pretty resilient with the temperature, but when it comes to the salinity, they are way more sensitive. And with hardness, I would really have to ask Dario to help me out here because she's the expert.
Okay. Yeah, let's move on to the second one with Camilo, and then I give chance to all of the presenters, and then Leroy can comment on this question in a few minutes. So let's go to the Camilo's presentations. Camilo, there are only very good presentation, couple of questions. I know you already answered it. If you want to add something extra, it's open opportunity to right now to do so. One question is, you already answered this one regarding did you have the chance to already upscale such nanoparticle to get an idea of manufacturing cost, shipping, logistics, handling, and mixing in the field, especially when considering 0.05 to 3 kilogram per cubic meter?
Hi, everybody. Hi, Mary, and all the staff from the program committee. Thank you again for the invitation. And yes, as I showed in the presentation, there have been some field trials regarding nanotechnology and convergent technologies application. And in this case, specifically for the CEOR, I can say that, for example, the amount of concentration was reduced drastically about more than 50% with a little amount of nanoparticles. As you saw, we in fact were able to inject a relatively low concentration of surfactant, or I mean the surfactant and the fluid, up to 300 ppm, which is low, and it has a cost effectiveness. It will depend on the type of process that you are conducting. For example, the cost will be different when using polymers, for example, and when using tracers. But once you evaluate the technical efficiency of the system and the net cost for the implementation, you will find a great outcome in the process. So this has to be evaluated like a whole system, not just how much cost the nanoparticles or the nanofluid. Also, other two recommendations in the case of polymer fluid, the literature reports high concentrations. For example, I have seen papers with 0.5% or 1% of nanoparticle, which is too much for the injection and injection production system. We have found that even with 10 ppm of specifically designed nanocomposites, you can have a high efficiency by inhibition, the polymer degradation by several mechanisms at the same time, and even you can increase the system efficiency by reducing the amount of polymer that you need. This will also depend on the type of reservoir, and we also say that these developments need to be tailored for each of the cases. Other recommendation is that you have to focus on have the nanofluid prepared before you are going to the field, because the managing of the nanoparticles could be some trouble under field conditions. So having the surfactant nanofluid or some kind of nanofluid that make the injection easier under field conditions will be of high priority. And once in the field, depending on the concentration, if it is too high, you need to look for the stabilization of the nanofluid before injection. Because as you know, if you have an injection production system, you will need the nanoparticles to be stable for a long time. So you need to guarantee that nanoparticles are stable and that the injectivity will be okay during several particle volume of injection, talking mainly about the near well phase.
Okay, thank you. Thank you very much, Camilo. I think you also answered the question on the question regarding the concentration in your answer. I will go to Dr. Liero. First, sorry if I mispronounce your name. And there is one question. If you want to add any additional comments, you're welcome to do so. The question is from Anthony Thomas. Thank you for presentation. I have two open questions. Why do you think chemical EOR implementation is very limited onshore, US lower 48 states, despite the fact that the potential for implementation is rather high? The second one is, you touched a little bit about simulation. Do you see tangible improvement, especially for modeling polymer? I personally see a lot of flaws in the approach, some not making physics sense. I would be happy to hear your opinion.
Hello. Thank you for your question. So I'm going to go with the first question and correct me if I understood right. So the first question is related to the EOR application for offshore. Is that correct?
Yes, I believe it should be offshore, although the question is onshore.
Okay. Well, the polymer flow is the more mature technologies on the chemical EOR. And we have pilots already in offshore. However, until just a few years ago, polymer has certain limitation, high salinity or or high hardness, like a calcium, magnesium concentration, and also high temperature. I think right now, polymer flow is not limited by those parameters, because the supplier has polymer available that can be used in seawater, typically offshore. The injection is seawater, without removing the calcium and the magnesium. So I don't see the limitation from the point of view of chemistry, from the point of view of the molecule. Maybe the limitation comes from other aspects, like a facility. I know facilities offshore are much more complicated to make up the polymer and handle all of that. But we should be able to do polymer flow offshore in these days. So when we talk about surfactants for offshore, it can be offshore or it can be onshore. The important point of surfactant is there are many surfactants and they are sensitive to the salinity and to the temperature. The key is the knowledge to generate the right combination, the right surfactant blend that can have a good fit for the specific reservoir condition. And I know that some people around the world have been developing specific formulations of surfactant polymer, especially surfactant polymer when you refer to offshore, in the way that if they can avoid issues of scale, because ASP have more issues of scale. It does answer the question for offshore.
Maybe mic is off.
Yes, I think you answered the question, but one of the other question is regarding the modeling and simulation. It's something I have been also dealing with it a lot. As you know, the polymer modeling is not that complicated. It's because applying the water. But the question is there any new advances on the when we go in polymer modeling? I know there can be a lot of discussion on surfactant, but the question is going to polymer modeling.
Yeah, well, I know I'm expert in the simulation, but I interacted with so many people that work in this area. And when they were running even simulation for our group, one of the important points in the simulation is before, years ago, and it's in some of the articles published, the simulator didn't capture some of the fluid rock interaction parameters. They were not part of the simulator. So to match the field application with the simulation, the matching was not really good. But I understand now that there are much more input in the simulator related to the fluid rock interaction parameter. And the parameters that we get from the lab development and all the lab property and core flow are now input in some of the simulators. I wanted to mention that the group of Dr. Pop, now it's led by somebody else, but the group that has been an excellent work, a lot of work in trying to input parameters in the UTK. And I know some companies that doing simulation participate in that consortium. So like they learn what are they doing at the level of UTK, and that is the simulator for the university, and they can take that input and see, or that knowledge to see how I can do similar thing in my commercial simulator to make it better. So that's
I appreciate it. Yes, yeah, I agree. When we talk about simulation and modeling, most of the time the underlying models, the model has not been properly matched for even. There's a lot of issues going to the model itself. Then we adding chemical, it's going to be a little bit more complicated. Let's move to the next presenter, Fernández Rodriguez. Thank you very much for your presentation. There is one question here. in regard to, I believe a high polymer viscosity was injected during the pilot. Did you experience any problem of injectivity or other unexpected behavior in the field that you presented? And you can also add some additional comments if you want to open a discussion in that regard. We don't hear you. Can you unmute? Let me
Unmute.
Okay, go ahead. Oh, still is not.
Okay. Thanks again for the invitation. Yes, the polymer solutions were injected in the polymer of Petrocedeño fields. The viscosity were in between 900 and 1,600 centipoise. After several analyses using pressure test information, it was reported that only 30% of the horizontal section was receiving polymer. Afterwards, there are no additional publication concerning this topic. We hope to have new information regarding the injectivity, the mobility control, etc. of this pilot test in Petrocedeño. Is clear? Yes? Okay. I can't hear anything.
Mehdi, your mic is off. Mehdi.
Oh, sorry. Thank you very much. I don't see any more questions for the last presenter. However, I will open if she wants to add something. It's open for the question. Dr. V. Sorry for my mispronunciation your name. If you want to add something to the audience, or you're welcome to do so. If not,
yes, Mehdi. Actually, I got a question for all the panelists. Looking forward, our surfactants and polymers today, with this decarbonization challenge and circular economy concept, applying your knowledge on chemistry and engineering and processes, how circular economy can be part of the surfactants and polymer processes. Can we reuse part of our products or subproducts in our oil and gas industry chain value that come into the surfactant polymers and try to do this circular economy to make EOR, but as well include this type of options? It's a question for all who would like to come. Lidio?
Well, you are more the expert in that point. You did a very good presentation at the beginning. The way how I see this is it's really difficult to reuse it. This formulation, this polymer and surfactant, and maintain the expected results, because the formulation is altered by the absorption at the interface. So the way how I see the benefit is based in some of the presentation that some of the people from SNFD that they show by using polymers, how they can reduce the amount of water, how they can produce more oil, and only the fact that we get much less water, that is going to align to the goals of sustainability and many of those trends that we are going through now in the oil industry. So, but I don't see how polymer and surfactant can be reused and have the expected efficiencies of recovery factor planning and the application for enhanced oil recovery.
Thank you, Lidio. And Camilo. Yes, John.
Yeah, no, so I fully I agree with Lirio. There is one project we're doing in Canada. They don't clean their water. So it's a polymer injection project. Water is not being cleaned. It goes straight back up again, and we top it up with more polymer, and then it goes back down again. Now, this is kind of a special case, because normally, you know, this is not always applicable, but for this one, it works. And we top it up, so we get like 15 to 25% polymer back, and then we top it back up again to the 100% polymer. So there is a kind of a precedent that one could do that. Like Lirio said, for surfactants, and if I did go back into my, you know, put my old Shell hat on, mainly you try to design a surfactant to be completely efficient, because it's really expensive. So you don't want to back produce surfactant anymore, because otherwise you just lose money. And therefore I don't see the surfactant being circular, like you said. And to answer your question, so polymer, you know, between 15 and 25% could be circular, but the surfactant will never be circular. And then on top of that, you've got your co-surfactant, you've got your alcohols, you've got your all the other chemicals that go in there. So I don't see that really as something we can do. I see it more like, okay, let's just attack the CO2 question. Just to answer your questions, you know.
Thank you, Jan. Thank you. I appreciate your answer too. Yes, definitely. No, and there are some processes that cannot be, that we need to put more efficiency inside the process to make more sustainable. But it's something that we should work on. Thank you, Jan. Thank you, Lirio. And coming to Camilo with the nanotechnology, I think with the nanotechnology work, this circular economy concept related to how we can handle is something that you are working on, no, Camilo?
Yes, with nano and biotechnology. It is because you take advantage of all residues. For example, we have synthesized some biofluids and nanofluids with some rice husk or coffee husk, that it will contribute to this circular economy. And we are currently evaluating the reduction of CO2 footprint when using nanofluids. So in this part, I should disagree with Lirio and her opinion, because I believe that with more efficient systems, we can have lower emissions and not just focus on the capture and storage, because I am more of the line in looking for the co-production of energy and the reduction of the emissions instead of capturing. Why I'm saying that? Because we know, because of our calculation and because of some field trials, that when you use nanofluids, you reduce, for example, concentrations. And if you increase the system efficiency, you can reduce, for example, the energy needed for the injection. And when you do that, you are certainly reduce the emissions that you are going to cause. And also, if you can produce more with less, you are also reducing the amount of water, the amount of time, the amount of emissions. And for example, in thermal enhanced salt recovery, the trick is looking for systems that are lower energy consuming. So in this sense, once they produce water with polymers or surfactants, I'm more in the line that it should be cleaned or it should be designed to self-cleaning products, such as self-degradable polymers or self-degradable surfactants can have this possible, and not just for the reuse of the water, but also for the disposal. Currently, there is a high problem in the disposal wells, in which the quality of the water is not suitable for the injection, and you need a high energy consumption for the disposal of the water. So checking this out, you will reduce the environmental impact of the produced water and the CO2 footprint of injecting this water. And in the same line, you can have different optimizations for reducing this CO2. We should have another session in which we can talk about energy co-production and CO2 emission reduction in enhanced oil recovery.
Okay, thank you, Camilo. So it's good to put this now into the panel. So, so let's see how we can go further with this type of options and alternatives, as Camilo mentioned, and Lidio and Dr. Jam as well put together. In our hands is the option to do the best way to do with the efficiency and cost effective for the projects and how make it into the expansion. As Fernacel is working on the renewable system, how you put this one on the environmental constraints and conditions, because this is a fragile ecosystem you are in, no?
Yes, it is. Yes, it is. In La Faja Petrolífera, what they are trying to do is some parts, some pilots with thermal, with low environmental impact. Let's say some research on in-situ combustion with nanoparticles, hydrogen donors, etc., with acid gas sequestration, and another projects in areas where we cannot inject steam, apply chemical flooding. So in this way, this is the best way to try to find a compromise between production and environmental aspects. Yes.
Thank you, Fernacel. And that is the way that we should put this together, how we're going to go on the way that we are doing today. So thank you, Fernacel. And putting this option is something that we mentioned as well. I don't know if there is another questions, Mehdi, from your side.
Andy, you might be muted.
No, Cesar, I think from my side, everything is okay. So we can move ahead for the next item on agenda and the closing. And thank you all. And Cesar, the floor is yours.
Thank you, Mehdi. Okay, now just to put everything together is how we have been seeing today in the full agenda since the beginning to now to the end, how our mature field has a lot of opportunity, and with our EOR perspective, we can work together, either operators, companies, research and development groups, service provider companies, academia, government and institutions, to put the different scenarios to make profitable our energy, but as well put energy efficiency, circular economic concept, energy storage, renewables, CCUS, natural capital options to put together on that. So with that, I would like to say thank you to all of you for being here. Thank you to the task force that today, with a exemplary manner, thank you, Sol, for the amazing job. Thank you, Mehdi. Thank you, Sebastian. Thank you, Tarek. Thank you, Laura, for the great work have been done with all the volunteers we're working. We are collecting now more volunteers for the other task forces. We have the thermal recovery task force. We have the gas flooding technique task force, dynamic reservoir, and emerging technology task force. So like this, we can work on the following webinars, reports, and options that we're going to put together. So invite you to please, if you would like to participate, please answer the survey. Let's meet in a couple of months in our net webinar together for the next adventure on this. Thank you on behalf of the International Energy Agency and the ESCON meeting of the EIRTCP. We will continue working with our community to put together all this knowledge and all this technology together. So thank you very much for all. Appreciate your time today. Really so happy to have all of you here. Thank you.
Thanks, everyone. Enjoy your weekend.
Thank you.
Thank you.
Thank you, everyone.
Bye-bye.
Good to see you.
Thank you.
Thank you. Bye.
Thank you.
Thank you very much.
Thank you.
Thank you all, Cesar. Thanks all for organizing everything. It was really appreciated. It was a great session. Thank you.
Thanks, Jan.
Thank you.
Thank you so much.
Thank you. Bye.
Thank you, Fernández.
Thanks, David.
Gracias, Fernández.
Gracias. Hasta pronto. Feliz día.
Feliz tarde, feliz fin de semana. Happy weekend.
Igualmente.